Let us solve another question on the same data which we had in the previous question. Now let us look at this. This question and the data is the same, but now we are asked about the tag directory size as one of the previous questions. Okay, now let us look at this. Question is the same, but now we need to find out the tag directory size, okay, in the system. Now, in order to find out the tag directory size, first of all, we need to find out the tag size and the number of blocks, because the tag directory is equal to, you know that, tag directory is equal to number of blocks into tag size of a tag. Okay, just we know already what are the total number of blocks here, and let us see once again. Total 32 initially will be divided into index plus tag. This practice we already did in the previous previous session, but once again I'm going to explain you. The index is equal to, what is index? Index is equal to cache size. Cache size is equal to 256 kilobyte. In order to represent 256 kilobyte cache, we do require 18 digits. So index is equal to 18 and the tag is equal to 14. Tag is equal to 14. And again, index will be subdivided into word field, and this is number of blocks. This is number of words per block. So word field is equal to block size. As you know, what is the block size? Block size is equal to 32 bytes. If you want to represent 32 bytes, you do require 5 digits. So 18 minus 5 is equal to 13. This is the block, that means this is the block field. That means we do have a total number of 2 power 13 blocks. Okay, so number of blocks are equal to 2 power 13. This number of blocks will never change, either in the direct mapping or set associative mapping or 4-way or 8-way. Only sets will get reduced, but not the number of blocks. Okay, so in that light, number of blocks will still be 2 power 13 into, what is the tag size? Tag in 4-way set associative mapping will be different. The tag in the 4-way set associative mapping, as you know that, block is equal to block minus 2, tag is equal to tag plus 2. Okay, number of tag bits is equal to 16 here, right? As the number of tags is equal to 16, we must multiply with the number of blocks to find out the tag directory size. But here, as in the question, there will be some additional digits attached to the tag. Okay, that is, each tag directory entry, each tag entry contains, in addition to the regular tag, that is address tag, 2 valid bits, 1 modified bit, and 1 replacement bit. Altogether, a total of 2 plus 1 plus 1, 4 digits that are additional to the tag. So 4 plus 16 is equal to 20. 20 into 2 power 13. Okay, so tag directory size is equal to 2 power 13 is equal to 8k. Okay, 8k into 20 is equal to 160 kilobits. 160 kilobits. 160 kilobits is the answer. Okay, so for the first question, number of bits in the tag field will be 16, you know that. But now we are asked about the tag directory size. When it comes to the tag directory size, we must multiply the number of blocks with the tag. But tag has also some additional digits which are equal to 4 here. Altogether 20 plus 8k is equal to 160k is the answer for this.